Good morning, everyone. First, we'll be finishing the doubts of waves, chapter waves, if any. Last time we were discussing H.O.T.S. Stationary waves, assignment number 3, H.O.T.S. Everything was discussed. Please check. So, as far as stationary waves is concerned, we are done. As far as wave motion is concerned, I gave you the complete solution, but we could discuss up to 25th question. We could discuss up to 25th question. So are we all on? Wave motion, assignment number 5, H.O.T.S, page number 105. Are we on waves, assignment number 5, wave motion, assignment number 5, H.O.T.S. Question number 26 to 30, anything? Question number 26 to 30. I advise you to revise this and come. I advise you to go through the doubts and come. Right? I know right now you are not getting time at all, and that's the reason when I give the homework, I take care that it is within your time limits. My homework is hardly 45 minutes, 1 hour. 26 to 30 में किसी को कोई doubt? 26 बेटा दिखने में लंबा चौड़ा दिख रहा है, but if you observe it very carefully, then can I say A is giving you 3 bits and B is giving you 2 bits, right? So the answer should be 341 plus minus 3, या तो 341 plus minus 2, and then you have to apply the logic of on loading the frequency decreases. So दिखने में लंबा चौड़ा question दिख रहा है, but otherwise it is easy. Question number 27 and 28 are Doppler effect. Maths students, if any, Doppler effect and melodies will be done with you later, right? First, I am just finishing the common syllabus, which is common for all. So 28, 27, I hope you have marked this as Doppler effect. 29th is easy. Delta F is equal to F1 minus F2. So 1 upon delta T is 1 upon T1 minus 1 upon T2. Question number 30, super duper important. Super duper important is a combination of 3 chapters. It is a combination of 3 chapters. ध्यान से देखो बेटा, question number 30. Velocity of a transverse wave is given by under root T by mu, and it is also under root S by rho. Chapter waves. Chapter waves. उसके बाद में PCM students particularly, PCM students, बिल्कुल बेटा आप लोगों को ये पार्ट है नहीं, right? Elastic constant is given by stress upon strain, and therefore stress can be written as elastic constant times strain, right? Here that elastic constant is given as Young's modulus. So this is the involvement of second chapter, second subtopic, which is elasticity. First chapter, second chapter. So I can substitute this stress as Young's modulus times strain, and therefore now I will get the formula as velocity of a transverse wave is under root. Stress can be written as Young's modulus times strain upon rho. ये जो मैं intermediate formula लिख रहा हूँ ना, they also can be MCQs. Mind you, PCM students, be careful please. ये जो मैं intermediate formula लिख रहा हूँ, they also can be MCQs. Now strain, as you know, is change in length upon original length upon rho. Now here there is a third chapter involved, and that is thermal properties of matter. Thermal properties of matter. So this is the last formula. Velocity of a transverse wave is also given by y upon rho times delta L upon L is, याद करो बेटा, alpha delta theta, where alpha is coefficient of linear expansion and delta theta is temperature difference. Everybody understood? So check. You have to first come to the final formula and then you have to substitute. Check the problem now. Young's modulus is given, density of the wire is given, coefficient of linear expansion is given, and difference of temperature is given. In some exams, this itself had come as a question. Identify the correct formula of velocity of a transverse wave from the following. Right? So you have got 4 combinations of y alpha delta theta upon rho. It may be y rho delta theta upon alpha. It may be y alpha upon rho delta theta, and so on. Identify the correct formula. Is that clear? Must question tha beta, must question tha. Mark it 5 star. So this was question number 30, assignment number 5, wave motion, H.O.T.S. क्वेश्चन नंबर 31 से 35 में किसी को कोई डाउट? क्वेश्चन नंबर 31 to 35 में किसी को कोई डाउट? I have given the solution in a very lucid language, very simple language. So I'm sure when you read the question and compare it with solution, most of them will get it. Yes sir. Still, question number 31 to 35 में किसी को कोई doubt? Sure बेटा. Question number 36 to 40 में किसी को कोई डाउट? 38 बहुत सिंपल है. क्या कर रहा है? पावर अपॉन एरिया. तो इसमें फ्रीक्वेंसी उल्लू बनाने के लिए दिया है. पावर डायरेक्ट दिया हुआ है. एरिया कैन बी रिटन एज 4 पाई आर स्क्वायर बिकॉज इट इज अ स्फेरिकल सोर्स. आर इज द डिस्टेंस. द कॉन्सेप्ट ऑफ वेव फ्रंट. अगर ये बेटा पॉइंट सोर्स ऑफ लाइट है, इधर देखो, अगर ये पॉइंट सोर्स ऑफ लाइट है, राइट, और ये डिस्टेंस ऑफ द ऑब्जर्वर है, ये डिस्टेंस ऑफ द ऑब्जर्वर है, ये डिस्टेंस ऑफ द ऑब्जर्वर, डिस्टेंस ऑफ द ऑब्जर्वर कहीं पे भी हो सकता है. So can I say point source of light will give you wavelengths in forward direction, and then the locus of all this will be a spherical wavefront. So can I say intensity will be power upon area where these waves are reaching. That area will be 4 pi r square, where r is the radius of spherical wavefront. So frequency उल्लू बनाने के लिए दिया है. It is power upon 4 pi r square. So it is power upon 4 pi into distance square.
So 40th में वो मीटर होना चाहिए ना 19.6.
Sorry बेटा.
40th में 19.6 मीटर्स होना चाहिए.
19.6 मीटर होना चाहिए. हाँ बस. वो लास्ट टाइम बोला था मैंने करेक्शन में. शायद आपके बैच में नहीं बोला होगा बिकॉज दिस वाज पॉइंटेड आउट बाय सच स्टूडेंट. रेड पेन प्लीज. क्वेश्चन नंबर 40 में the stone is dropped in a well which is 19.6 meter. It is not centimeter, it is meter. It's a printing mistake. Yes. एक बैच में बोला था मैंने, पता नहीं कौन सा बैच में, याद नहीं है मुझे, बट ये बोला था. और 41 का मिस्टेक भी बोला था मैंने. 41 में the second line is printed as 4.0.1. It should be 49.1 centimeter. Question number 42 to 45 में किसी को कोई डाउट? 41. Okay. Each of two strings are 51.6 centimeter and 49.1 centimeter. मतलब इनका लेंथ अलग अलग है, but they are tensed separately by 20 Newton force. मतलब they are under the influence of the same tension. The mass per unit length of the string is same. That means mu is same and is 1 gram per meter. 1 gram per meter in the sense 10⁻³ kilogram per meter. That is mu. When both strings are vibrating simultaneously, then what are the number of bits? What is the formula for a vibrating string? What is the formula for a vibrating string? F is equal to 1 upon 2L root of T by mu. अब इसमें क्या वेरिएबल है? L, see frequency का formula is 1 upon 2L root of T by mu. Can we say over here length of the wires are different? F is equal to 1 upon 2L root of T by mu, and therefore F1 is 1 upon 2L 1 root of T by mu. And F2 is equal to 1 upon 2L 2 root of T by mu. Because उन्होंने बोला है दो अलग अलग वायर्स है लेकिन उनका लीनियर डेंसिटी सेम है. They are under the same tension. That means there are two separate experiments performed. But in both these wires you are applying the same tension. That means you are suspending the same load. उनका मटेरियल भी सेम है. एक कॉपर है तो दूसरा भी कॉपर है, लेकिन क्या सेम नहीं है? उनका लेंथ सेम नहीं है. लेंथ 1 कितना है? लेंथ 1 वैल्यू वाइज 49.1 and length 2 51.6. Apply common sense. L1 is less than L2. Yes or no? So F1 should be more than F2. Thank you. Right? F1 should be more than F2. इसका मतलब डेल्टा F हुआ बेटा F1 minus F2. अब ये दोनों में क्या कॉमन है वो कॉमन ले लो, और क्या कॉमन नहीं है? L1 कॉमन नहीं है, L2 कॉमन नहीं है. इसका मतलब 1 upon 2 कॉमन, अंडर रूट ऑफ T by mu कॉमन, अंदर आएगा 1 upon L1 minus 1 upon L2. Yes or no? So दोनों वायर में टेंशन कितना है? 20. What is the linear density? 1 gram per meter. That is 10⁻³ under root आ गया ये. And this also will be under root. This is 1 upon 2 root of T by mu. This is 1 upon L1 minus 1 upon L2. So this is 1 upon 49.1 minus 1 upon 51.6. और ये सेंटीमीटर में था, जिसको मैं मीटर में कन्वर्ट कर रहा हूँ. रीजन इसको मैंने मीटर में कन्वर्ट किया था, और ये ऑलरेडी न्यूटन में था. एवरीबॉडी Have you understood the step? Right? Solve this. You will get the answer. This was question number 41. 42 to 45 में कोई डाउट? उसमें बेटा बाइनोमियल थ्योरम करना पड़ेगा. Reason, the temperature values are very close. Are the temperature values 15 and 10? Are the temperature values 15 and 10? I told you that throughout the chapter there are two frequencies coming sometimes in the same problem. Tuning fork का frequency always take it as capital F. Wire का frequency या तो pipe का frequency take it as small f. So in question number 42, a column of air, that means its frequency is small f, and a tuning fork they give 4 bits per second. The tuning fork gives lower frequency note at 15 degrees Celsius, right? And when the temperature falls to 10 degrees Celsius, the number of bits reduced by 1. पहले 4 bits था, अभी 3 bits है. ध्यान से सुनो बेटा, ध्यान से सुनो. पहले तो डेटा सुनो. Can I say F1 is equal to F plus 4 and F2 is equal to F plus 4 minus 1? Because the number of bits is reducing by this. So this is F plus 4 and this is F plus 3. क्योंकि उन्होंने बोला है कि ट्यूनिंग फॉर्क का फ्रीक्वेंसी इज अ लोअर फ्रीक्वेंसी. That means pipe का frequency is a higher frequency. That's why normally when we take bits, we take F plus minus 4, F plus minus 3. मैंने डायरेक्ट इधर प्लस लिखा because इसका frequency lower. Point number 1. ये टेम्परेचर कितना है? What is the first temperature value? 15 degrees Celsius. So is it 288 Kelvin? And what is the second value? 10 degrees Celsius. That means is it 283 Kelvin? Yes or no? Now can I say first frequency, bit frequency is F plus 4 and next is F plus 3. Can I say velocity at 15 degrees Celsius upon velocity at 10 degrees Celsius is F plus 4 upon F plus 3 because velocity is F lambda. So direct relation. Greater temperature, smaller temperature. Greater frequency, smaller frequency. Because as temperature increases, velocity increases. As velocity increases, frequency increases. Right? And this is under root 288 upon 283. अभी इसको बेटा बाइनोमियल के अलावा कोई चॉइस ही नहीं है अपने पास. Reason, if you square this up, right? Then this will be F plus 4 the whole square. This will be F plus 3 the whole square. Very lengthy calculation. So my suggestion would be F plus 4, F plus 3. इस बार बेटा बायोलॉजी स्टूडेंट्स ध्यान से सुनना बराबर. Is it 288 upon 283 raised to half? अब इसको आप राउंड ऑफ भी नहीं कर सकते हो, राइट? इसको आप राउंड ऑफ भी नहीं कर सकते हो बिकॉज राउंड ऑफ करने के बाद भी कुछ ज्यादा फायदा नहीं है. दिस विल बी 90, दिस विल बी 285. सो माय सजेशन वुड बी you can write it this way: F plus 4 upon F plus 3 is equal to 288 can be written as 283 plus 5 upon 283 upon 283, splitting the denominator. Yes or no? A plus B upon C is A upon C plus B upon C. So this gives me F plus 4 upon F plus 3 is equal to, PCB students ध्यान से बेटा, 1 plus 5 upon 283 raised to half. Now here we can use binomial theorem saying that power becomes coefficient. This term is going to be very small number. This term is going to be very small number. So higher powers of 10 can be neglected. Higher powers can be neglected. For example, if I write 2 upon 3 the whole square, I cannot neglect this. But when I write 2 upon 30 the whole square, 2 upon 300 the whole square, then the higher powers will become very small. अब जैसे स्क्वायर के कंपैरिजन में क्यूब सोचो बहुत छोटा हो जाएगा, रेज़ टू 4 बहुत छोटा हो जाएगा, यहाँ पे भी वैसा ही होगा. So over here higher powers will be neglected. So this will be 1 plus power becomes coefficient times 5 upon 283. And this is F plus 4, F plus 3. अब इसको मल्टीप्लाई कर दो. This is 1 plus 5 upon 576, right? 576, 280 का डबल 560 and 566. Sorry. So this will be 1 plus 5 upon 566. Then you take LCM and then you cross multiply. मतलब टाइम कंज्यूमिंग होगा, लेकिन कोई चॉइस नहीं है. बट द एडवांटेज इज विद द ऑप्शंस. अगर मेरा फर्स्ट डिजिट 1 आ गया, फर्स्ट डिजिट, तो मुझे बाकी का 3 देखना ही नहीं है. अगर मेरा फर्स्ट डिजिट 4 आ गया तो भी मुझे बाकी का 3 देखना ही नहीं है. पंगा सिर्फ कब आएगा? जब मेरा फर्स्ट डिजिट 2 आया. तो मुझे 2 ऑप्शन में से डिसाइड करना पड़ेगा कौन सा. इसमें फर्स्ट डिजिट डायरेक्ट 1 आ रहा है, इसमें फर्स्ट डिजिट डायरेक्ट 1 आ रहा है. कैलकुलेशन स्टफ था इसका, कैलकुलेशन स्टफ था. पीसीबी स्टूडेंट्स बी केयरफुल. This was question number 43. 43 डॉपलर इफेक्ट है क्या? यस. 43 डॉपलर लिखवाया था. 43 डॉपलर इफेक्ट. 45 स्किप करना है बिकॉज इट इज रिपीट. 54th क्वेश्चन असाइनमेंट 1 वर्ड टू वर्ड. ये हो गया बेटा वेव मोशन हॉट्स असाइनमेंट 5 का डाउट्स. Now there were 3 very simple articles pending. Very simple articles pending. Same book, continue. Waves. Page numbers 9 and 10. या तो 10 and 11. एकदम starting वाला chapter. Wave motion. Again, the first chapter. We were left with Quinke's tube experiment. We were left with reflection of sound from a plane surface. And we were left with reflection of sound from a curved surface. Very simple article, one by one. Are you there on page number 10? Absolutely simple. Mirror याद करो बेटा, mirror. Look here everybody, mirror. If it is absolute plane mirror, absolute straight, no zigzag. This is the normal drawn to the mirror. This is the incident ray of light. This is the point of incidence and this is the reflected ray. And we say that angle of incidence is equal to angle of reflection. Mind you, this was with light. Sound follows the same philosophy. Same philosophy. Suppose I am giving you a pipe. Suppose I am giving you a pipe or a tube or cylinder. And this is source of sound. This is source of sound. Suppose this is a tickling clock या तो watch. And clock, preferably. Sound wave is entering. Sound wave is going to move in all directions in 3 dimensions, right? But we want to collimate the beam. The word to collimate means to focus, right? So we will just receive these sound waves, and these sound waves are traveling in this tube. Okay, this particular part, in place of normal, I will have a partition which is absolutely soundproof. That means this wall which you see is absolute soundproof wall. इसका मतलब sound cannot go directly on this side. Sound cannot go directly on this side. Suppose I am performing this experiment in this classroom. This is the wall of the classroom, and over here there is source of sound. You are the listener on this side, and the source of sound is this way. So sound goes, absorb. Sound goes, absorb. Sound goes, receiver is on this side, listener is on this side. So wasted. Sound goes, wasted. That means when the sound wave comes this way, या तो this way, right? Only this much part is kept open. Very small part is kept open. And you are the listener on the other side. You don't know where the sound is coming. So you are also ready with a hollow pipe. You are also ready with a hollow pipe. And you are just putting it this way. And you are just changing the angle of incidence. Right? So when you change the angle of incidence, your tube is here, your tube is here, your tube is here, your tube is here, and so on. Yes or no? When the tube is here, you will not hear the sound. Tube is here, not hear the sound. Tube is here, you will just hear the sound. Tube is here, not. इसका मतलब at one particular angle only, you are receiving this sound wave. So like light, it proves that angle of incidence for a sound wave is equal to angle of reflection for a sound wave. Look at the diagram. Very simple. If you look at the diagram, then also you will understand what are they trying to say. So this is reflection of sound from a plane surface. Now reflection of sound from a curved surface. This technique is usually used in auditoriums, church, theaters, etc. This is a concave reflector. This is the focus. So the speaker is here, right? This is the audience. For example, it is a long hall in a church, right? These are the listeners. These are the listeners. This is the wall. This is the wall. There are doors over here. There are doors over here. There are doors over here. There are doors over here, and so on. Right? Now, preacher is giving the speech. Father is giving the speech. So this sound waves come to you directly. This sound waves come to you directly. This sound waves come to you directly, directly, and so on. But this sound waves which are going this way, they will be wasted or else they will be absorbed. Answer is no. This is a concave reflector where this sound wave goes, and it is reflecting back to the audience. In place of going this way, it is coming this way. In place of going this way, it is coming this way. In place of getting wasted, it comes this way in the audience. It comes this way in the audience. मतलब आपको ओरिजिनल डायरेक्ट साउंड तो मिल ही रहा है, रिफ्लेक्टेड साउंड भी मिल रहा है. It is type of no sound wave is wasted, and this particular length is kept less than 17 meter, so that echo effect is not there. Otherwise पता चला कि एक sound wave इधर से आया और एक reflect होके इधर से आया, so we will be getting a confused pattern. Yes or no? What they have shown is they have shown two reflectors, right? Concave reflectors. What I have shown is this one, and this one is flat. अगर दोनों concave reflector होगा तो क्या होगा? This is concave reflector. This is the focus of that. So here you have to put source of sound. This is another concave reflector. Over here you have a listener. Over here you have a listener. So sound wave goes, reflects, reflects. Sound wave goes, reflects, reflects. And this is the direct sound wave. Right? If you suppose you are blocking the direct sound wave by putting some soundproof material in between the source of sound and the listener, then the reflected one will be reaching the listener. Is that clear? Check the second diagram of that page. Check the second diagram of that page. Very simple. Here in between S1 and S2, if you want to put some soundproof material, that is also okay. Because the one which is going to the concave reflector, it will reflect from there and it will reach the listener. The third one which was pending was Quinke's tube experiment. Quinke's tube experiment is nothing but a beautiful demonstration of interference of two waves. And if they are sound waves, then this interference is going to result into formation of bits. Now see what is happening over here. You will be given two C-shaped tubes. This is one tube which is a hollow cylinder. So this is a C-shaped tube, or you can say U-shaped tube. And this is another C-shaped tube or U tube, like this. And this is having a diameter smaller than the left one. This is having diameter smaller than the left one. The first one is a fixed tube. This one is a fixed tube. This is clamped over here. With the help of a stem. This is the real life experiment. Okay, this is clamped over here. And this one is movable. So suppose this tube is A, B, C. And this tube is X, Y, Z. That X, Y, Z is movable. That means you can hold it from here, move it closer, get it away. You can do that. Over here, there is an opening. This is called inlet. And over here, there is another opening. This is called outlet. Right? Now over here, you are going to put some source of sound. So suppose I am putting a vibrating tuning fork over here. So when the prongs start vibrating, they will send this sound pulse in this tube. The sound enters. The moment it enters over here, you have given provision to the sound wave to move into direction. Right? That means sound wave goes this way also and sound wave goes this way also. So let me call this is sound wave number 1, which is going through the tube ABC. This is sound wave number 1. and this is sound wave number 2, which is going through tube XYZ. This is sound wave number 2. Obviously, this length difference, this length in fact, and this length are not going to be the same. Check please. This length is this much, right? This much. I'm just shading this. This length is this much. Yes or no? This much. Because this is where the sound wave will come out from. This is where the sound wave will come out from. So the green one and the blue one will interfere with each other, and what you receive over here, you can put a receiver over here, which may be the screen of the computer where you can receive the sound waves, and they will be converted into digital waveforms. So you can understand, and it will be in the form of a bit wave, because when there are two sound waves coming with slightly different frequencies, इसको बेटा कम टाइम लगेगा इधर आने में, इसको ज़्यादा टाइम लगेगा. That means timings are not same. That means frequencies are not same. So F1 is not equal to F2. So delta F is equal to F1 minus F2, and therefore you will get this pattern like loud sound, loud sound, soft sound, loud sound, soft sound. You will get a bit wave. So Quinke's tube experiment is nothing but experimental confirmation of interference of two waves, which over here will be resulting into phenomenon of bits. Okay, very simple. So over here, because the lengths are not going to be the same, you will have path difference या तो length difference, which we call it as delta. If this is even integral multiple of lambda by 2, that means you are getting maxima, what you call it as vexings. And if it is 2n minus 1 या तो plus 1 lambda by 2, that means you are getting minima. Apply common sense. V is known to you. F is known to you. F is known to you. Frequency of the tuning fork. That means you can easily calculate lambda. And now check that pattern. These are going in even integral multiples or odd integral multiples. And it is very evident. When you put your ear here, right, and gradually suppose your table partner is moving this tube away and close, right? Or if this tube size is small, usually it is about 1 meter. So sometimes your hand may not reach, right? So your partner is holding this tube and moving it, and you are hearing this. Next time you are holding the tube, your partner is hearing this. This will be loud sound, soft sound, loud sound, soft sound. So that is interference of two waves, right? Very simple. I want you to revise page number 9. And with this book is over. With this book is over for PCB students. PCM students, one lecture on Doppler effect, one lecture on Meldis, right? That I'll be taking at the end, when the common portion is done with you all. I'll take extra lecture on Doppler effect and Meldis experiment. Okay, please revise page number 9. Please revise page number 9. And we stop here.